All right, everybody. It's been requested and suggested that I can make a video for you guys doing Gauss-Jordan row elimination by hand, start to finish. So you have something you can watch and listen to me talking about it. So here you go. I just started us off with this problem. It's a 3x4, so 3 rows, 4 columns. And what I want to point out is this is about the same level of difficulty as what I'd ask you to do on a test, okay? I'm not going to give you crazy hard problems. It's just to see if you know the process. So here we go. First things first, we have to make sure all of our variables are lined up in the all in the same columns. So make sure your x's are all lined up, your y's are all lined up, your z's are all lined up, and your equal signs are all lined up. Of course, equals always have to go on the right-hand side. So now we write it in our matrix. So -1, 2, -1, augmented 0, -1, -1, excuse me, -1, 2, 0, 2, 0, -1, 4. Okay. Now, as we go through this here, I'm going to try and keep talking about the big ideas. So first things first, our eventual goal, we want to have something that looks like 1's in the diagonal, 0's everywhere else, and then our numbers, whatever the answers may be, will be on the right-hand side. But one key thing I find students doing is they always try and force these numbers immediately to be 1's. They don't have to be. If you want to work with them as a -1, so right now we have a -1, if that makes your life easier, leave it. We will be able to change that at the end. So, to make a point, I'm going to leave it as a -1. So, the thought process I now go through is I say, what do I multiply row 1 by and row 2 by, so that way when I add them together, I get a 0. I mean, note, all we're really doing here is using these two equations and saying, using elimination technique, what would I multiply one of these rows by, so that way when I add them together, I get 0 for the x's. So you can see, since it's -x and -x, I just need to multiply one of them by a negative, one of the equations by negative, and that will get me the opposite sign. So if I did that, I get -x minus 2y plus z, not 2, try again, plus z is equal to 0. Then I leave the other one alone, -x minus y plus 2z is equal to 0. And then for elimination technique, I'd add them. So I get 0x's minus 3y plus 3z's is equal to 0. So now I'm going to do the same thing, but I'm just going to do it using matrices. So I'm going to say I want to multiply, I want to multiply my row 1 by a negative, add it with my row 2, let me get this out of here. Multiply by row 2, and my goal is to make a new row 2. Now, when I do this, you can do a little bit of side work if you're not so much the mental math person. You say, okay, take my row 1, multiply all the numbers by a negative. So that makes a +1, -2, +1, 0. Now, I'm going to add that with my row 2. -1, -1, 2, 0. When I add these two rows together, there we go, I get 0, -3, 3, 0. So when I go to write my new matrix, -1, 2, -1, 0, my new row 2 would be 0, -3, 3, 0. Go back and look at the coefficients of our of this problem when we did it using elimination. 0, -3, 3, 0. 0, -3, 3, 0. So the idea here is all we're really doing is elimination technique. So if there's any rule that you could do in elimination, such as multiplying an equation by -1 or +4 or whatever, you can do it in matrices. But anything you can't do in matrices. So for example, can I go here and just add +1, +1, +1, +1? No, because these aren't like terms. So don't try and do that in your matrix. Okay, hope that made sense. So now, I didn't do any computations for my third row, so it stays the same. So now I am not done pivoting off of this number. I still have to use this top left number to get zeros all below it. So what do I multiply row 1 by, so that way when I add these together, I get 0? Well, I could just multiply 2 row 1's plus row 3 to make a new row 3. So I'm not going to do this side work. If you want to, go ahead and do it on your own. You pause the video and do it on your own and catch up, or, and see if you get the same thing. So what I'm seeing here, we're leaving these first two rows the same. So now my third row, 2 times row 1, so that's negative 2 plus 2, that makes 0. 2 times 2 is 4 plus 0, that makes 4. 2 times negative 1 plus a negative 1, so it's negative 2 plus a negative 1, so that makes negative 3. 2 times 0 plus 4 makes 4. So now I ask myself, am I done using this pivot? Well, yes I am, because it has zeros below it. So now I'm ready to move on. So I move down my diagonal to the next pivot. So now I'm going to use this number to get zeros above and below. So I ask myself, do I want to leave this as a negative 3 or do I want to change it to a 1? What's easier? Well, one part of that thought process I use is there easy multiples above and below? Is there an easy multiple of 2 and 3? Well, I could make it 6, and then 3 and 4, I can make it 12. But then the other part of the thought process is if I just divide, or multiply by 1/3, but for this class we're okay with dividing. So if I multiply, or sorry, wrong way, switch it around. If I divide row 2 by a negative 3, does that make nice numbers? Oh, well, yeah, it does. So I'm going to do that. So negative 1, 2, negative 1, 0, 0, 1, negative 1, 0, 0, 4, negative 3, 4. So I may be more inclined to use this division if the numbers are nice whole numbers or easy fractions. But if it turned out to be something horrific, divided through by 17, and I have to do all sorts of crazy fractions, I might not do it. I just might work with the big numbers. So, long story short, we're ready to pivot. We have a 1 there. It's easy. Let's use it. So, I'm going to do negative row 2's plus row 1. Oh, wait a second. That's not going to work. I need 2 of my row 2's. So I do negative 2 row 2's plus row 1 to make a new row 1. And if you kind of do the side work, so negative 2 times row 2, so that's 0, plus a negative 1, so that's negative 1. 0. Negative 2, so that would make a positive 2. Positive 2 minus 1 makes positive 1. And then these are both 0, so it's just going to be 0. Now, second line stays the same. Now, to save myself a bit of work, or a bit of writing, I'm not going to write the third row and then keep going, and then pivot again from the same one. I'm going to do them all at one time. So I'm going to say to myself, what would I need to multiply row 2 by? So that way when I add it with row 3, they equal 0. That's a negative 4 row 2's plus row 3 to make a new row 3. So now when I do that, I end up getting 0, 0. So negative 4 times negative 1 makes positive 4, minus 3, that makes 1. And then that's just going to leave me with a 4. So now as I work again, I say, okay, I'm done with that pivot because I have zeros below. I'm done with that pivot because I have zeros above and below. So I'm ready to keep moving down my diagonal to my new pivot. So I'm going to use this number to get zeros above. So now this is a little easy because I just need to add row 3 and row 2 to get a new row 2. And then to get row 1 to get a 0 up here, I'm going to, again, negative row 3 plus row 1 to make a new row 1. So now that I have that, the only row that doesn't change is my third row. So sometimes I personally like to fill it in before I get started. And now I'm going to fill in my row 2. So row 3 plus row 2, so 0 plus 0 makes 0. 0 plus 1 makes 1. 1 plus negative 1 makes 0. 4 plus 0 makes 4. Now, up to my row 1, negative row 3's plus row 1. So negative 0 plus a negative 1 makes negative 1. 0 and 0 makes 0. Negative 1 plus 1 makes 0. And negative 4 plus 0 makes negative 4. So I'm almost done. Last thing I need to do is just say, now is where I worry about all of these numbers in the diagonal actually being equal to 1. If there's not, I can just go through. Now I just go through and divide the row by whatever number I need, or multiply the row by whatever I need to make it a positive 1. So I can take row 1, multiply it by a negative 1 to get a new row 1, and the other ones are fine. So that will leave me with 1, 0, 0, 4, 0, 1, 0, 4. and 0, 0, 1, 4. So now reading my answer, remember this is my x column, y column, z column, equal sign. So I'm just seeing x equals 4, y equals 4, z equals 4, or 4, 4, 4. Okay, I hope that helped. I will say there was one other thing I wanted to say. If you notice the pattern that I use, every time I do any row operator, I always start with my pivot row. So you notice I was pivoting off of row 1, so I started with row 1. Again, I was pivoting off of row 1, so I started with row 1. Pivoting off, now I pivot off row 2, so I start with row 2, row 2, so row 2, row 2. And then when I was pivoting off of row 3, I started with row 3, row 3. And if you notice, I always have adding. So the only thing I make negative would be my pivot row. So you see that right there is -2. The reason why is it preserves the signs as you move throughout the problem. If you don't use that pattern, you'll still get the problem right. Sometimes you just have to do a little more work multiplying things by negatives. But long story short, it's just my own little pattern. Use it if you, well, not my own. It's something I've learned somewhere along the line. But use it if you like it. Don't use it if you don't. But I hope the video helps.